Another video. In this tutorial, we are going to look at how we can handle this particular problem, find a constant so that the function is indeed a PMF. Okay, so this is the function that we have. Okay, this is the function we have, f of x equals c into 9 on 10 x minus 1, right? But x is equal to 1 to infinity. So this is a continuous PMF. So the continuous PMF, if you want to handle it, you have to know that the summation of the function, okay, the summation of the function from that particular limit, okay, the summation of the function, okay, from x equals 1 to infinity, okay, the summation of the function from x equals 1 to infinity of this f of x should be equal to 1. So that is the condition for a PMF to for a function to be a PMF. This is the condition. Okay, so what we have to do first, what we have to do here is that we have to sum all the necessary informations here. This one is up to infinity and see if it will be giving us 1. So we'll find from summation from x equals 1 to infinity of the function. This is the function we have, and that should be giving you 1. Okay, so now we have the function summation x equals 1 to infinity of the function, which is c into 9 on 10, right? X minus 1. Okay, we sum this, okay, we sum this to infinity because x equals 1 to infinity. You see 3 dots over there, so that means infinity. So it's continuous, so we take it as a continuous function, then we sum 1 2 3, then we do dot 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 dot. Okay, so that is how we are going to do it. So we sum this function, okay, and that should be giving you 1. Okay, so from here we're saying that summation from x equals 1 to infinity. So we're going to start from x equals 1. So 9 on 10 power x minus 1. So x, we are considering x to be 1. So 1 minus 1, okay, plus c into 9 on 10, okay, 9 on 10 power 2 minus 1 plus c into 9 on 10, okay, power 3 minus 1. Okay, so this goes to infinity because we don't know the end. You can sum up to infinity. So what we do is that we leave it at 3 dots. Okay, so we leave it at 3 dots and then we equate it to 1 because when you sum everything, it should be giving you 1. Okay, so this should be giving you 1. Okay, so that is what we have. Okay, so we simplify this, then we see what formula we are going to use because this we cannot find the sum with this real calculation, just mere algebraic calculation. So we have to use the sum to infinity. Okay, sum to infinity because x from x equals 1, it approaches infinity. So we have to use the sum to infinity formula. So from here, we can say that c into 9 on 10 power 1 minus 1 is 0 plus c into 9 on 10 power 2 minus 1 is 1 plus c into 9 on 10 power 3 minus 1 is 2. Okay, so we have these informations here, 3 dots, 3 dots, and that result should be giving you 1. Okay, so from here we can see that c, the constant, is running through, so we can factor that out. So when we factor the c out, we can have 9 on 10, right, exponent 0 here, plus 9 on 10 exponent 1 plus 9 on 10 exponent 2 dot 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 plus 2, and that should be equal to 1. Okay, so this is what we have. Okay, this is what we have. Okay, this is what we have. So now we are coming to use the sum to infinity formula. The sum to infinity formula. Okay, so we know that the sum to infinity formula is giving us a over 1 minus r. And here, from these informations, we can see that our a is equal to 1. Okay, because this one, when you break it down, let me break that down before we start the process. Okay, so from here we can see that we have c into 9 over 10 power 0 is basically 1. So we have 1 here plus 9 over 10 exponent 1 is 9 power 9 over 10 plus 9 over 10 exponent 2 dot 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 plus to infinity, right? And that should be equal to 1. Okay, so from here we can see that we can now use the sum to infinity formula. So when we do that, we can say that sum to infinity formula, sum to infinity formula, which is the x subscript infinity. So that is equal to a over 1 minus r. And here our a, which is the first term, is 1, and our ratio is 9 on 10. Okay, so once we have these informations, we can say that c, you see we have c factored out here, so we can say that c out, right, c out into our a, which is 1, all over 1 minus 9 on 10, 1 minus 9 on 10, and that that information should be giving you 1. Okay, so once we have this, we can go ahead and do the necessary computation. So from here we can say that when we simplify this very well, we can say that c into 1 on 10, right, is equal to 1, right? So we can say that we have 10c is equal to 1. So we have c equals 1 on 10, right? So that is the constant. That is the constant. So now we have our constant to be 1 on 10. So we can now rewrite the function as, so now our function is equal to c, which is 1 on 10. Okay, now our c is 1 on 10 into 9 on 10, right? exponent x minus 1, x equals 1, 2 to infinity, 0 x squared. So this is our new function. Okay, so this is the function now without a constant, because we have had the constant to be 1 on 10. That is the first question that we were asked to do. Now, the second question said we should find the probability of x greater than 10. This is also telling you that we need probability of numbers, values of x that are greater than 10. Can you do that? You can't do that. So what you have to do is that you have to break it. You have to break it. You take 1 minus those less than 10. Okay, so you take 1 minus probability of x less or equal to 10. Okay, so probability of x greater than 10 will be equal to 1 minus probability of x less or equal to 10. Right? So once you do the probability of x less or equal to 10, then you can do the rest of the work. Okay, so now let's find the probability of x less or equal to 10. So from here, we can say that 1 minus probability of x less or equal to 10 will be equal to probability of x equals 1, okay, plus probability of x equals 2, plus probability of x equals 3, right? Up to probability of x equals 10. So this is what we can do. We can't find probability of x greater than 10. We have to, break it, take the complement. Okay, so we take 1 minus probability of x less or equal to 10. Then we have probability of x greater than 10. Okay, so from here, we can say that probability of x greater than 10 will be equal to 1 minus probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3 up to probability of x equals 10. Okay, so when you do that, we are going to have 1 minus 1 over 10. You know the function we had 1 over 10 into 9 on 10 exponent x minus 1. So now we are coming to substitute x equals 1, x equals 2, x equals 3, x equals 2, 4, up to x equals 10. See the workload. Imagine doing x greater than 10. It's going to be very tough. That is why we cut it, we break it to have probability of x less than or equal to 10. Then we take the complement. So here we have 1 on 10 into 9 on 10 exponent 1 minus 1 plus 1 on 10 into 9 on 10 exponent 2 minus 1 plus 1 on 10 into 9 on 10 exponent 3 minus 1, right? Plus 1 on 10 into 9 on 10 exponent 4 minus 1 plus 1 on 10 into 9 on 10 exponent 5 minus 1. So this we do it up to 1 on 10 exponent into 9 on 10 exponent 10 minus 1. Okay, so we do up to 1 on 10 into 9 on 10 exponent 10 minus 1. Okay, and that will be the probability of x less or equal to 10. Okay, so we take 1 from the result. Okay, so we are going to have 1 minus whatever probability of x less or equal to 10. No? Then we will have the probability of x greater than 10. Okay, so from here, we can say that when you do that calculations very well, you're going to have, you know, this calculations, you see, we are going to have 1 on 10 into 10, 9 on 10 exponent 1 minus 1, and that is 1 on 10 into 9 on 10 exponent 0. That is basically 1. Okay, it continues up to exponent 9. So this one we have to use geometric sum. So with the geometric sum, we're going to have we're going to have we're going to have we are going to have Sn is equal to a into 1 minus r over 1 minus r, right? So here we know that our a is 1, our r is equal to 9 on 10, and also our n is equal to 10. Okay, so the first term here, 9 on 10 exponent 1 minus 1 is a 9 on 10 exponent 0. So basically, you're going to have this first term to be 1, and the rest follows. So the rest, you see, we are having the same ratios, 9 on 10, 9 on 10, 9 on 10. So 9 on 10 becomes our ratio, which is r, and a, which is the first term, which is 1, and n, which is 10. That is probability of x less or equal to 10. So n becomes 10. So here we say that we're going to have 1 minus 1 on 10, okay, into 1 minus 9 on 10, right? Or exponent 10, right? Or exponent 10. Okay, so all over 1 minus 9 on 10. Okay, so this is what we have now. So this one, when you simplify it, you're going to have 1 on 10 into 1 minus 9 on 10, all right, or exponent 10 over 1 on 10, right? So from here, we can say that our geometric sum Sn, which is where our n is 10, is going to be 1 minus when you do every calculation here, you're going to have into 1 minus 0.34 0.3487, right? So this one, you're going to have 1 minus that, right? 1 minus that, and that is basically when you expand this, you're going to have 1 minus 1 plus 0.3487. So we have our answer to be 0.3487. So that is, we can say that probability of x greater than 10 is equal to 0.3487. So that is the solution to the second part of the problem. So that is the process we go through to analyze this particular problem. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye bye.